Good morning, everybody. Hope you're ready for another installment of Organic Chemistry Learning. Coming at you today, starting out the week off right. And yes, I know you're saying, my gosh, look, Stu's wearing a t-shirt, but I don't often get to wear it. I only get to wear this one periodically. Yeah, I did that. I went right there. Yeah, it's true. All right, so what we talked about last time were the homologous series, the anes, the enes, the ynes, right? And it was basically just hydrocarbons. And all we really do with hydrocarbons, because all I've ever talked about was we just burn it, right? That's what we do with methane, we burn it. Propane, we burn it. Octane, we burn it. And anything in between, we burn it. Anything more than that, well, if it's more than 8, then you have diesel fuel, and we burn it. And if it's even more than that, then you get wax. So you know what we do with that? We put a wick in it and we burn it. So not much going on with straight hydrocarbons other than burning. And in the beginning of the chapter, I'm all like, man, chemistry, the organic chemistry does like everything. Like all the the chemistry of life. It's like, oh, it does everything, blah, blah, blah. But how can it do everything if all we talked about was like lighting stuff on fire? Well, this is how, right here. These guys. See these things? The functional groups? This is what it is. So if you take like a hydrocarbon, if you pop off a hydrogen and pop something else on, typically it's only going to have to be an oxygen or a nitrogen. Bam. Once you do that, then everything changes. That's when you go from like just straight hydrocarbons into like the weird things that make up, living things. Do you guys get what I'm saying? So there's these things called functional groups. No, right there. Wait. Here, let me point like that. Yeah, right there. So it's anything that replaces a hydrogen in a hydrocarbon. We're going to call that a functional group. Now, this is like a Pandora's box, man. There's like gajillions of things that can count as functional groups, but we are going to start with the basics. And we are not going to memorize anything, okay? Right over here, we have table R. And that is what we're going to use for our functional groups. Squirrel. So these are all the functional groups you're ever going to need. This is what they're called. So we got right here. We've got the class of your compound, like what the name of that category is. The functional group, in other words, what has replaced the hydrogen to make it all trippy and weird. The general formula, this is something I want you to pay attention to. You see this right here? That R? That R means, it means like, it represents the rest of a hydrocarbon. So whenever I see R, the first thing I think of is like the rest of the hydrocarbon. So there's usually a big long chain coming off of there. And here is a wonderful example. Isn't that delightful? Oh, really. And what I really want you guys to dial in on here in this example part is this is how you're going to remember how to name them. Because, again, you shouldn't memorize it. You should, use these tables. So, if you see, here we have halides. We have fluorine, chlorine, bromine, or iodine smacked into a hydrocarbon. Here's how we name it. 2-chloropropane. Because on the second carbon, there is a chloro, right? There's a chlorine, and it's a propane, right? So remember, if we were going to build it, we build these things backwards. So we start here, and we go over this way. So this one, meth, eth, prop, must have 3 carbons. What is on it? A chloro, or a chlorine. And where? Where is the chlorine? Well, it's on the number 2 carbon. You get what I'm saying? And if you can't remember between chlorine, fluorine, and bromine, there it is right there. Everything you're going to need to know. It's like right there on the table. Okay? So these functional groups, anything that replaces hydrogen on a hydrocarbon, that's what makes things like switch over into like the land of trippiness from just like a straight up hydrocarbon. So group by group, let's start with halides, shall we? Halides. Man, hydrocarbon with a halogen. It's really all there is. That's really all there is to it. You need to see it and name it, and you also need to draw it. So let's just start drawing a few, because you guys should have a pretty good solid grasp of naming. It's like root, what, where, and that was with the branched alkyl groups. Same thing with halides, right? So we're gonna draw some stuff in a minute. Yeah. So root, what, where, right? So for this one, 1-fluorobutane. Yeah, so the root here is butane, right? So we can make butane, meth, eth, prop, but. 4 carbons. If I can't remember, you go to the table. You got your P's and your Q's. So I'm just going to go meth, eth, prop, but. Awesome. Now, that was the root. The what says fluoro, so that means fluorine. Remember, you go back up there to the table. Fluoro, that means they've got a fluorine on the number 1 carbon. So I'm just going to put that right here. That was super easy, right? Now, the next thing we need to do is we go through and we give everybody hydrogens. So the carbon has how many bonds? 4, right? So here we got this carbon has 2, 3, 4. 2, 3, 4, 2, 3, 4. Ding, ding, ding. Done. Get it? Good. Let's do the next one. Right? You see how that works? This next one is going to follow the same pattern. Root, what, where. It's just a little more complicated, but it's the same basic rules, right? So this one is propane. Meth, eth, prop. Okay, 3 carbons. I can draw 3 carbons. Good morning. All right. So that's the root. The what says chloro, so I've got chlorine in there somewhere. Where, right? Root, what, where? On the 1 and the 3. So that means I must have a chlorine here, and I have a chlorine here, and then I put hydrogens everywhere else. So I'll put an H, 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 H. That was super easy. I'm not scared of halogens. Neither should you. Actually, I am scared of halogens. They're wicked, crazy poisonous. I don't know if you guys remember the whole ozone layer that was opening up that people were concerned about. It was caused by things like this. Chlorofluorocarbons. They were hydrocarbons with both chlorine and fluorine attached to it, and they would put it into the aerosol cans because it expanded and worked really nice with like hairspray and things like that. The problem was there was so much of it going into the atmosphere that as it floated up, it reacted with the ozone in the layer, which really, who cares? It's the ozone. It's toxic, right? But way up in the stratosphere where the ozone layer is in our atmosphere, that stuff, like I don't know if you remember the allotrope of ozone, it makes a triangle. That actually reacts with gamma rays coming in from like outer space, from the sun, and it reacts with them and basically acts as a filter for really, really nasty radiation that if it came down, like if there was no ozone, we would all have cancer by going outside. Like it would be really bad for us to lose the ozone. Cancer rates would go because it acts as basically a radiation filter around the surface of the earth, which is why life is allowed to be here, because we've got this beautiful ozone there. We, in our geniusness, almost killed it with these things, halides. But now we're not, because we're hopefully not that dumb. But, who knows? All right, so moving on. The next functional group. Oh, what I did here is I took a little clip from the big table so you could just see each little category, right? So alcohol. Here's the deal with alcohol. There are actually majillions of different kinds of alcohol, and there is only one kind of alcohol that gets you drunk. Only one, right? But there are bajillions. And that one specific kind of alcohol has to have 2 carbons. If you drink alcohol with 2 carbons, first you will get drunk. If you keep drinking it, even before then you will pass out. But if you drink too much before you pass out, the real issue there is that it is such a depressant that it can actually stop your respiration from happening. It happens like every year at Penn State. At least one kid dies from it. It's really terrible. But if you take that 2 carbon alcohol and you cut off just 1 carbon, so you have just a 1 carbon alcohol, that one is commonly referred to as wood alcohol, and that will kind of get you a little bit drunk. Like you'll feel a little bit weird, and then your retinas will peel from the back of your eyeball, and then your liver will stop working, and then you're dead. So make sure it's the 2 carbon and not the 1 carbon. Oh, also, if you took your 2 carbon alcohol and you added an extra, now you had 3 carbon alcohol, guess what happens there? Well, pretty much the same thing. You get kind of drunk, you feel a little bit silly, then your retina starts to degrade off the back of your eyeball, and your liver starts to seize up, and that stops working, and then you die. So make sure you got the right one. So when I talk about organic chemistry, and I'm like, structure is important, we need to know the shape of it. Dude, Like, seriously, it's the difference between a martini and I don't know what there's a word. I don't know what it's a word for that. That just a big, weird shaped glass of poison. So here's the deal. An alcohol, all it has, so the group name is called alcohol, but all it is you pop off hydrogen and you place it with a hydroxide. Now that it's organic, we call it hydroxyl. So it's an OH. It's just an OH group. That's all the thing. That's all it takes. So if you take ethane, which it's really like, methane is like a bubbly gas from like swamps, can blow up. Ethane is the same thing, only 2 carbons. If you add an OH on it, suddenly it like sticks together as a liquid and is alcohol that you can drink. And here is what the general formula looks like. Remember, this is like the rest of your hydrocarbons, so that's just a bunch of carbons, and this OH is just sort of stuck to it. And here is the example for the name. So alcohol ends in all. Right, so that's why I want you to see that, and there it is. There's our functional group. You got it? So a couple things to remember. That this OH group, now that we're in organic, it's called hydroxyl group, not hydroxide. We call it hydroxyl. And again, it's this YL ending here. Remember with the branched hydrocarbons, like all the branches ended in YL? The reason we do that is so that we know that it's a branch of a hydrocarbon. You get what I'm saying? So instead of calling it a hydroxide, we call it hydroxyl, because hydroxide says that it's like, in water with acids and bases, right? Like aqueous chemistry. Like that's kind of what we've been doing all year. But when we end it with ol or YL, that tells us right off the bat, we hear and we know, okay, we're dealing with like a hydrocarbon, organic chemistry type stuff, right? Okay, unlike most of their counterparts, like their hydrocarbons, alcohols totally dissolve in water, which is why we can have beer and wine, and why we can have like rubbing alcohol and whatnot. And the reason it can do that is because of this, the hydroxyl group. It's half of a water, so that's kind of where all the water sticks to and sort of like does its whole dissolving action. And they are non-electrolytes, so they do dissolve, but they are non-electrolytes. So in other words, when they dissolve, when water starts doing its like dissolving process with like the positive end and the negative end sticking and grabbing, it doesn't rip. The water does not rip this thing apart when it dissolves. It just surrounds it, right? So if it was ionic, it would rip it apart and make ions. It would be an electrolyte. We could conduct electricity. But alcohol, non-electrolyte. That's important to know because it's a fundamental characteristic of these things. You put it in water and they don't break apart. Thank God, because that means that we would dissolve every time it rained. And I really enjoy swimming. I don't think I would want that to happen. I would totally ruin my day. And for us, at least, 3 basic categories of alcohols. There are primaries, secondaries, and tertiaries. We're going to break those down a little bit more, and I want you to remember that the alcohol ends in all. Right, so here's where we're going to get into it. Like the homologous series, we call ane, ene, ine, right? So what we do is we change the ending so we know exactly what the shape is, like what we're dealing with. So if it's like hexane, we know it's just all single bonded hydrocarbons, right? We're gonna burn it. Hexane burns like crazy. It's good stuff. So if we say hexanol, instead of hexane, we say hexanol. We know that it's a 6-carbon alcohol. For whatever purpose we need a 6-carbon alcohol for, probably a industrial solvent or something like that. You guys get what I'm saying? That's why we change the endings. It identifies the functional group. It tells us what we're dealing with. Got it? Good. I hope so. Here we go. All right. So if we took methane and we converted it into an alcohol, which we can do, this would be called meth. No, not ane. We're gonna change the ending. We're gonna get rid of that, and we're gonna go all. Methanol. And now, what is the shape of methanol? So we took a methane. It started out as a single carbon hydrocarbon. We're gonna turn it into an alcohol. So it's going to be a carbon, and all you do, remember, you're gonna take one of these hydrogens, pop it off, and then you're gonna take an OH group, and you're gonna pop it on. There, methanol. if you ever hear of if you ever hear of like a chemistry teacher or like a science lab that blew up in school and people got all burned, it happens a lot less as the years are going on. Like I've been teaching for a lot of years, so when I first started out, was at least once a year somebody blew up their lab. This is the stuff right here, methanol. Woo! That stuff is like, it's actually not fun explosive. But this stuff is fun. Butane is. So butane. Remember, let's take it. We're gonna get rid of the E, get rid of the ending, and because it's an alcohol, we're gonna put on an OL. So this is butanol. Right. So if we take butane and we add an OH, it turns into butanol. And there should have been some kind of number there. So we go meth, eth, prop, but. I'm going to change this right now. There, I just edited it. To butanol. So, whoa. So, guess where my OH group goes? Yep, right here. And the rest get hydrogens. 1, 2, do. There, hydrogens. That was really quick. All right, so you guys see how the name changes? How you just take the E, get rid of the E, turn it into an OL. Otherwise, it's all the same. This prefix here is just the same as before. It tells you how many carbons. And yes, I messed that up. I'm not going to lie. I made a mistake again. First of the day. Right. It's like, I'm just getting warmed up. This tells us where, right? The number tells us where. So it's same thing as always. Root, what, where, but the ending here, this ending tells us what category we have, like what kind of functional group. Let's move on, because like I said before, there are 3 types of alcohols, and we should know them so that we are smart people, because that's what we are. We are learned and educated. Sort of, for the most part. Most of the time. Some of you guys more than me. That's true. All right, so primary alcohol. So primary means 1, right? So see how that degree, I don't know why they chose 1 degree to mean primary, but it does. But basically, it means that the hydroxyl group bonded to a carbon has only 1 other carbon bonded to it. So here's how I look. Here's how I tell. First, I circle the hydroxyl group and its carbon. See? So the hydroxyl group and its carbon. And if you see, it is bonded to how many? 1 other carbon. That makes it primary. Also, if it is primary, that means that the hydroxyl group is on what we call a terminal carbon. In other words, it's at the end. And if it's at the end of a chain, that's going to make it far more reactive if we want it to react and whatnot. You guys get what I'm saying? Okay, so again, primary alcohol, the hydroxyl group and its carbon. The hydroxyl group is attached to a carbon that is bonded to only 1 other carbon. Okay, so let's check out secondary. So secondary is where your hydroxyl group is bonded to a carbon. See how I'm circling them? My hydroxyl group is bonded to a carbon that is attached to 2 other carbons. Right? So do you see how this is now an interior carbon? It is not on the end. So the thing with my secondary carbon is that it is not on the end. It's more inside the chain, which like lowers the reactivity of it. You got it? So that's, again, the hydroxyl group is bonded to a carbon that's attached to or bonded with 2 other carbons. That's how we get secondary. Now, the question for you is, could you imagine what a tertiary carbon might look like? It's bonded, right? So you got your hydroxyl group is bonded to a carbon attached to how many other carbons? Yeah, it's 3. Oh my gosh, it's great. All right, so this one, once again, we got your carbon and your hydroxyl group, and you look at how many carbons is that guy bonded to. It's bonded to 1, 2, 3. 1, 2, 3. This is tertiary. This is rubbing alcohol. Way less reactive, because that's like kind of like in the middle. Doesn't really burn quite as well as like methanol or ethanol. That's why they put ethanol in gasoline, because man, does that stuff burn. Whew! And yeah, it's a problem. And one of the problems with ethanol, if you can imagine, so ethanol looks like this. Meth, eth. I'm just going to go off on a tangent here for a minute. Why? Because why wouldn't I? It's never stopped me before. So the problem is with ethanol is this, the functional group. right? It is not just a straight hydrocarbon. We have this, and that is water, right? It's like basically half of a water, which is the best solvent. So this thing starts interacting with some of those like gaskets and sealants and stuff and can kind of really mess with them. But what's even worse is that when this stuff sits in your gas tank, right, as your car uses up gasoline, there's a little air intake, so the air can go in and fill up the gas tank. Because, like, air, gas goes out, air goes in. Well, that air is coming from the outside, and it has moisture. And so we have little like here, so we can understand better. We'll have little like waters floating around in the air. All right. Well, what happens when water is floating around the air, bumps into one of these things? What kind of bonds happen between a hydrogen and an oxygen? Yeah, hydrogen bonds. So it sticks. And what happens is it literally pulls water out of the atmosphere. Now, if you drive a piece of garbage car like mine, it doesn't matter. I mean, you could probably pour water into the gas tank and it's still going to run because the engine is a very not high performance engine. It gets me from point A to point B. However, I have a friend who has a really nice Harley. Like it's clean. But he can't use gasoline that has methanol in it because it condensates water, it pulls moisture out of the air, and it messes with his engine big time. Same with my chainsaw. I cannot put methanol-based gasoline in my chainsaw. It is the worst because it pulls air, or it pulls moisture out of the air. It makes it run like garbage. So if you guys are running 2-stroke dirt bikes and stuff, don't find somewhere that has non-methanol gas. It'll run so much better because it keeps the water out of your gasoline. Because water does not burn. I don't know if you're aware of that. All right, aldehydes. I know we're going to skip a little bit out of order here, but I'm going from alcohols. See, alcohols with a hydroxyl group. I want you to take a look at that, to aldehydes, and there's a reason for that. There's a reason that I put aldehyde second because I was just talking about how alcohol is a beverage that we can drink, right? It's like in there. And there's this thing where like, everything in moderation, and you say like, oh, you're going to pickle your liver. Well, here's the thing. Y'all know what we do with aldehyde, right? With like formaldehyde. Formaldehyde is like an old name for just an aldehyde, right? I can't remember how many carbons, but it's not too many. I think it's 2 carbons, if memory serves me correctly. Like, methanol, the alcohol that you drink, right? So the alcohol that we drink is 2 carbons with an OH. Fun fact, the process that happens in our liver to break down the alcohol so that our body can digest it, like it's processed in our liver. You guys should know this by now because you have a pulse. The first thing it turns it into is formaldehyde. It has to break off that one hydrogen on the oxygen and make a double bonded and then so the hydrogen goes away. Then it's a double bonded oxygen to a carbon, and you literally have a molecule of formaldehyde. In small doses, it's not a problem. Our livers are crazy good at getting rid of stuff like that. It's what it's there for. It's like a toxin processing and getting rid of filter system. But if you drink too much too often, you literally will be soaking your liver in formaldehyde, and that's why you get cirrhosis of the liver, because formaldehyde is a molecule that is, as we say in industry, it is incompatible with life. Fun stuff. So let's look at aldehydes. So an aldehyde is basically what we call a carbonyl group, which is this. It's a double bonded oxygen, but it's important to know that it's bonded to a primary carbon. That's what makes it an aldehyde. It has to be a double bonded oxygen at the end, like on the terminal chain at the very end. So going back to the alcohol situation, right? We have meth, eth, anol, right? So our bodies, our livers break off that hydrogen in the first step of like metabolizing it, and we are left with 2 carbons and a double bonded oxygen. And this has to be on the end. It can't be on a secondary or a tertiary primary. It can't be on an interior carbon. It has to be on the end. And then it kind of does what it does. The ending, right here, al. So this is meth, eth. So we will go ethane. And then, right, because that's the number of carbons. And then we're going to get rid of that E. And then all is for alcohol. And then al is for aldehyde. See? And al, methane, al. So ethanal is an aldehyde with 2 carbons. You dig? Dug. Awesome. Let's name these things. Just as before. Meth, eth, prop. I'm going to skip the ending. So let's just take a look here. So double bonded carbon, it's on the end. So we come up to our table and look. Here, that's your hydrocarbon, carbon. And there's your double bonded oxygen at the end. Same with this thing right here, right? Your double bonded carbon is at the end of the chain. So our ending will be al. So this is propanal. Right? 1 carbon. Go back up to your table P. This is meth. Methane. But I'm going to change the ending to a double bonded carbon, or a double bonded oxygen at the end. Well, I guess there's only one, so it's a primary. Al. Methanal. Not methanol, methanal. The heck? 1, 2, 3, 4, 5, 6. Meth, eth, pro, hex. Hexane. Hexane. But I see that double bonded oxygen at the end, so I'm gonna erase the E. I'm gonna put al. Hexanal. The end. That's what I have to do. That's it. Yeah. Right. So the next one you can see right down here is a ketone. Now ketones are a little bit different than aldehydes. And again, it's like when you look at it on a piece of paper, it's like, what's the big deal? There's no real difference there. It's just it goes from the end to the like an ending primary carbon. Look over here, we have them in the middle, right? That's what a ketone is. But I want to remind you that this will kill you. You don't get to drink this and party on a Friday and then wake up the next day hungover. That's not how this one works. This one, you party on a Friday night and that's it. Lights out. This one, you can put that you can drink an amazing amount of that stuff and you'll wake up really hungover and feeling really terrible and stuff. But that's all. You're dead. Dead. If you drink too much, you're dead, but you get it? So even though these changes look small, the actual effect, like the result on the human body and other living things, like the result is just like astronomically huge. So let's keep going. Ketones. This is called a carbonyl group. Now a carbonyl group, right? Double bonded oxygen. This is now moved to an interior carbon. So this is where we get a secondary or a tertiary carbon. Completely changes the chemistry, like totally, believe it or not. Like, because this organic chemistry, this like chemistry of living things inside your body and whatnot, it is really stinking complicated. There is nothing clean and simple about this kind of chemistry. Except for us. And this, because remember, we're going to use this chart right here to remember everything. So before we do, let's go back here. Look, this is what it's going to look like. It's a double bonded oxygen, and there's going to be more carbons here, there's going to be more carbons here. It's like on the inside, right? And here's sort of another way, but look, this is going to be, oh, look, a number. Okay, so I'm going to have to tell us where this thing is, right? And it's going to end in, it's actually pronounced own, not one, but own. Besides, why would one, what, I hate the English. Anyway, so the ending is changed to own, right? And the number, as same with all the other methods, the number tells us which carbon our carboxyl group is bonded to, right? And as always, we use the lowest number possible because we need to know how close it is to the end of the chain. That's a really clean straight line there, because we need to know how close it is to the end of the chain so we know how reactive it is. So let's draw. Okay, so pentanone. All right, so if I got an one, You know it's a ketone. Pent means 5, and that's my 2. So that's going to be where? So, okay. So pentanone, 1, 2, 3, 4, 5, and 2. I'm gonna go from the left, right? So 1 carbon, 2 right here, double bonded, oxygen, hydrogens to fill it up. This guy has 1, 2, 3, 4. No hydrogens for him. He's full up. How about this little fella? That little fella needs 2. That little fella needs 2. That little fella needs 3. That was super easy. Let's move on to the next one. I have a feeling like we're gonna be pretty good at this. All right, 3 pentanone. All right, I see that there is a strange ending here. It's not ending in, it's not ane, or ein. So functional group. One means ketone. Pentan, pent. It's 5. Oh, look, the only difference is this. 3 pentanone, 2 pentanone. Okay, I can do this. 1, 2, 3, 4, 5. There's my 3rd carbon, and here are my hydrogens. So if you notice, these 2 compounds look unbelievably similar, and they will behave very, very similar. But inside a system as complex as a living organism, they will behave differently enough to have a profound difference. Got it? Great. Let's go to this one. Propanone. I noticed there's no number there, but it's not propane, propene, or propine. And so here's the silly ending, the "one," which, if you remember up here on this thing, the ending is "one" for a ketone. All right, so prop, F prop, 3 carbons. So I'm going to go 1, 2, 3, and this is why we don't need a number. Because, dude, if it ends in "one," right, you have to have a secondary or a tertiary. It can't be a primary or a terminal or ending carbon. It can't be on the end. It has to be on the inside, which gives us one option. Right now. I'm doing dots for hydrogens just for to be fast, so you don't have to sit here and listen to me ramble and side tangent for hours. Oh my gosh, it keeps going. It keeps going. All right, so this is an ether. Ethers. These are where we have an oxygen instead of like on the attached to a carbon, like on the end or like in the middle or something. This is where an oxygen is actually inside a chain of carbons. And then we have ethers. They are really stinky. Boy, they are some of the best solvents in the world. And here, look at this name here. Methyl ethyl ether. Say that 10 times. Say that 10 times. So watch. We have methyl, and look. First, there's a methyl group. Then our oxygen. And then look over here. Ethyl group. So first we have a methyl, then we have an ethyl, and it's an ether. So that's all there is to it. You say one group, you say the other group, you make sure everyone knows that it's an ether. So ethers, these are hydrocarbons connected by an oxygen. So here's your first hydrocarbon, there's your second hydrocarbon. That's it. That's all there is to ethers. Now to name them, each hydrocarbon is named as an alkyl group, so it ends in YL, and then you say ether, right? So let's try them. Let's try this one. This is a methyl. Oh, this is a methyl. I'm starting out complicated right off the bat. That's silly. So I have 2 methyl groups. So instead of saying methyl ether, right, we have a way of saying that there are 2 of something. Dimethyl ether. Dimethyl ether. 2 methyls and it's an ether, right? Let's go to the next one. This next one here, I've got 2 carbons, meth F, This one here is ethyl. Well, I've got two of the same thing. Diethyl ether, right? Because there's two ethyls, and it makes an ether. Two ethyls. Sounds like two little teeny old grandmas sipping tea somewhere. I wonder if grandma's still sip tea. All right, here we go. Methyl. Two carbons, ethyl. This one is methyl, right? Because that's my first group is methyl. My second group is an ethyl. There aren't enough people named Ethel. We need more. But they, if somebody was born and they were named Ethel, they'd have to instantly turn into an 80-year-old lady. That's the only person who can be named Ethel. And then this is an ether. There, methyl ethyl ether. There's the thing. You good? Does that make sense to you how that works? Name one carbon or hydroxyl group. Name the other hydroxyl group. Say ether. Oh, these are also wicked explosive. They light pretty good. But they also are really good. They'll also be used as solvents a lot, and also as ingredients in when you're manufacturing different chemicals. Ooh, oh, name to structure. Okay. Oh my God, how cute Juniper is. This is the most adorable little doggy I ever want to see. Aren't you, Juniper? She really is the most adorable thing ever. Okay, anyway, so I'm getting sidetracked. Your fault. Propyl. Meth-eth-prop. All right. Propyl butyl ether. Okay, so it's an ether, so I gotta have my oxygen in between the carbons, and so butyl. Meth-eth-prop-but. Sweet. Yeah. Easy peasy lemon squeezy. This is I could do. Oh! What? I should not be this kind to you already. It's only been I've hardly been talking for an hour. But that's it for today, boys and girls. That's enough. And then tomorrow what we're going to do is a little bit more of the same. I want you to work on this one. Halides, alcohols, aldehydes, ketones, and ethers. But don't memorize it. What I really want you to do is get your reference table, have your reference table right here, and learn to use your reference table to answer these questions. Because using tables is where it's at. Everybody can Google everything, but what we can't do is learn how to use that information, right? So everybody has all the information on the tips of their fingers, so you can go get all this information. But being able to use it, that's the important part. So halides, alcohols, aldehydes, ketones, and ethers for today. Yeah, I hope you guys had a wonderful weekend. I will. I guess I'll see you tomorrow-ish. Not really seeing you, which is weird. All right, man. Have a great day.